Alright, so hello everyone and welcome again to another science video lesson. And in this video lesson, we will going to talk about physics. And what topic on physics? That is projectile motion. Alright, so what do we have here in this projectile motion? Alright, so I know I created a lot of video, or there are videos already about projectile motion, the concept, and some sample problems related to projectile motion. But there is one special problem that I have right here that we will solve later on. And this problem has a lot of things, alright, to consider about a projectile. Alright, so let's get right into it. Alright, so this is the problem about the... Alright, this is the special problem that we will going to do on this video lesson. So our projectile is launched from a cliff of 100 meters above the level ground with a launch velocity of 30 meters per second and launch at an angle of 20 degrees above the horizontal. Determine the projectile's A, range, which is the horizontal displacement. We have the peak height, and we have the letter C, velocity up 2 seconds after the launch. Alright, so what makes this problem special? Number one, the object is launched at an angle. Alright, number two, not only it is launched at an angle, the object was launched above a level ground. And it will fall to the base of that level ground. Alright, so base of the cliff or whatever. Alright, so, and the third one, alright, the third one that makes this special is we will work on a problem. All right, we will work on a problem that focuses only on a certain time. All right, it will focus only on a certain time period, and that is 2 seconds. So let's find out what is the velocity of the projectile at 2 seconds after the launch. Alright, so I wonder what is the velocity of that object on that certain time period. Alright, so let's get right into it. So the projectile, maybe it is a cannonball. Okay, it is a cannonball. And let's take a look at this. So we have the range. We will try to look for the range and the peak height. So this is the Y max. Alright, and this is the X sub F. Alright, so that is the range. And the velocity at 2 seconds. Alright. So let's go to the first things first. In order to solve this problem, we draw a problem. Alright, we draw the problem. Alright, itself. Alright, so let's go to the handy dandy whiteboard. There you go. Alright, so before anything else, we start a problem with drawing a problem. So this is your cliff. Alright, and this is your level ground. So, okay. Alright, there you go. Then we will represent it as a cannon, something like that. And the projectile was launched at that position and goes right so. Okay. And now, alright, so and now, what do we have right here? Okay, so let's put on the given things, alright? So let's put on the variables that are given to us by the problem. Alright, so number one, so we have the launch angle. So the launch angle is 30, or rather 20 degrees, alright, above horizontal. So 20 degrees. Alright, next one, the speed. Alright, so the speed the object is launched is, alright, so the speed the object was launched is v sub I, that is 30 meters per second. Alright, next, the height of the cliff, this one, the height of the cliff is from this point down to that point is 100 meters. Alright, so we are asked to look for the following. Number one is the range. Alright, next one, number two is the peak height. So that is Y max. Right, so that's the maximum height. And after that, the velocity at 2 seconds. Alright, so these are the three things that we were going to look forward. And let's write down all the given values that we have right there on the drawing. So we have V sub I, that is 30 meters per second. We have the angle, which is 20 degrees. we have the height of the clip. So the height of the clip, we can have it. Alright, since the YF is the final height where the object falls down here, this is the YF. So this one will be your YI or Y initial, that is 100 meters, and the YF will be 0 meters. Alright. So, let's have the acceleration due to gravity, that is negative 9.81 meters per second squared. There you are. So what else do we have right here? Okay, I think we listed down everything. Alright, so we are looking for the range. I forgot to include this one. So we are looking for this. Alright, so how far did the... Okay, we will answer here. How far the object land? Alright, how far the object will land. Next one is how high the object is in air. Alright, so how high the object is in air. And the velocity after 2 seconds. So before we start the problem, let's have first all the computation or the toolbox. Alright, the tools necessary for this problem. So number one is the velocity or the x. Alright, so x direction formulas. Alright, so we have x sub f is equal to v sub ix times time. So this is your horizontal or x displacement formula. Alright, next one, number 2 is the velocity formula for x. So we have v sub x is equal to v sub I x. Alright, so next, number 3, we have the displacement at y direction. So we have y sub f is equal to y sub I plus vi y t and minus 1/2 gt squared. So there you are. Okay, next one, number 4 is the velocity at y direction. So we have vfy is equal to viy minus acceleration due to gravity multiplied by time. Alright, so these are the things that we need in solving this problem, and let's see which is the one that we will going to use in this problem. Okay, let's take a look. Alright, so number 1, we are looking for the range. Okay, we can have this. Alright, we can have this after we find the component of this one. Okay, we can have that. Alright, so our only problem is the time. Okay, so the time can be obtained not here but on number 3. Alright, so we can solve for x using this formula. So we can use number 1 and number 3. Next one, for solving for the y max. Alright, for solving for the y max, so we will use, since we know that the velocity on the top portion is, we know that the velocity here is 0. Alright, so we know that the velocity there is 0 at the peak height. So we can use this one, alright, in order to compute for the time, alright, the time it takes to reach the peak height. So this one over here. So we can use this one and integrate it on formula number 3. Okay, next one. Okay, so we can compute for the y max using 3 and 4 formula. And finally, we have the V2. Alright, so V2. Alright, so to compute for the velocity after 2 seconds, we will find out the components of your projectile at x and y respectively. Alright, so to compute for that, we need this one, the VIX. Alright, the VIX and then the VIY. So in short, we need this number 2 as well. Alright, so all of the formula will be utilized in this particular problem, the reason why it is so special. Alright, so first things first, before we start using this one, let's break this one. Alright, let's break this one into its, alright, let's break the V sub I into its x and y component. Alright, so here it goes. So we have, in order to break down the V sub I into V sub ix, we have V sub I cosine theta, and we have the V sub iy is equal to V sub I sine theta. All right, so there you have it. Then let's solve for the components of your v sub I. So we have 30 times cosine 20. All right, so let's do that very quickly. So cosine 20 times 30. So there you have it. So we have 28.19. All right, so let's make it 2 decimal. All right, so 28.19 is the v sub I x. All right, let's take a look at the v sub I y. So we have 30 times sine 20. All right, so there you go. Okay, so sine 20 times 30, so that will be 10.26. All right, so we have 10.26 meters per second. So we have v sub iy, and let's put it inside the box because this is a very important piece of number, all right, that we will going to use in calculating the range, the peak height, and the velocity after 2 seconds. All right, so let's use another whiteboard for that. Okay. Now, let's start first in computing for the range. So I will use it. I will use the black here. So this is for the range. All right. Now, in computing for the range, we will use the following formula. So we have x sub f is equal to v sub I x times time. And we have the next formula, which is y sub f is equal to y sub I, all right, plus v I y t minus 1/2 gt come on, squared. All right, so there you go. Okay, so obviously we cannot compute for the time there. We cannot compute for the time. So what are we going to do? Okay, we will use the second formula, this one over here, in order to compute for the time. So let's plug in the value. All right. So since there is no yf, all right. So since there is no yf, so we have it 0. All right. So we have yi, which is 100 meters. All right. So plus, what is the viy? So we have it earlier. We have 10.26, all right, multiplied by time. Okay, then minus 1/2 gt squared. Okay, there you go. All right, so since we have two components here that are missing, okay, we cannot proceed to the computation regarding the time here. But there's a way. We called it the quadratic formula. All right, we can use the quadratic formula because our format that we have right here is, okay, if this one is equal to 0, all right, so if this one is equal to 0 and we have a format of 0 is equal to ax squared plus bx plus c, all right, so if this is the format that we are seeing right now, so we can use the quadratic formula. Okay, so what is the quadratic formula? Now, in order to compute for the time, so we have, all right, in order to compute for the time, so we have minus b plus minus negative plus minus square root of negative of b squared minus 4ac over 2a. All right, so there you have it. All right, so what are these variables? Where are these variables can be found? All right, so let's start. So this will be your letter C. Okay, this will be your letter C, and this will be your letter. This is your letter A, and this will be your letter E. All right, so you can we can now plug in the values. All right, we can now plug in the values coming from our equation that you have right there. So for negative b, so we have, okay, so we have negative 10.26 because positive and negative multiply, that is negative. So plus minus square root. All right, plus minus square root. So for the b squared, so we have 10.26 squared minus 4 Alright, times the A, which is the 1/2 G. Alright, the negative 1/2 that you have right there. Okay, so multiplied by 100. Okay, next, divided by 4. Okay, sorry, rather 2 times negative 1/2 G. Alright, so okay, so after plugging all the values, if you do the math correctly, alright, if you do the math correctly, you will have two answers here. Alright, so you will have two answers here. One is, you have 2 time here. So we have, one is negative 3.59 seconds. And the other one is 5.68 seconds. Alright, so which one is correct? Alright, so which one is correct here? The correct answer here is the positive one, because there's no such thing as negative time, meaning to say that while you are holding that particular object, or before the object was launched, all right, before the object was launched, it was the time is already moving forward. Alright, the time is already moving forward, so meaning to say there's a backward time, something like that. Alright, so that is impossible. So the time that we computed right here is 5.68 seconds. Alright, so we can now use this one to compute for the range. So let's use this one for the range. So we have x sub f is equal to v sub I x times time. Alright, so what is the v sub I? So if we will go back to our previous component, so the v sub I is 28.19 meters per second. So we will use that here. Okay, so we have 28.19 meters per second, alright, times the time, which is 5.68 seconds. Alright, so meters per second, cancel. So our target answer is meter. So we have the range. Okay, the answer for the range is, so 28.19 times 5.68. So that will be 160.1. Alright, so that's 160.1 meters. Alright, so the number sounds reasonable. Okay, so we have a reasonable answer here of range 160.1 meters. Alright, so that is for the letter A, for the range. So let's go now to another whiteboard. Let's use another whiteboard for letter B. Alright, so for letter B, alright, so I will use a green pen here. So for letter B, we are asked to find out the peak height. Alright, so we have the peak height, or the Ymax. Alright, to be exact. Alright, so what are the formulas that we will going to use here? Alright, so number one, we all know that the velocity above, alright, at the mid height, or the peak height of the projectile is 0. So we can use this formula. So the velocity formula, we can use the v sub f y is equal to v sub iy minus gt. Alright, now if we compute the time, we can compute for the peak height. This is the peak height. This will now be the peak height, and we can now compute for it, and this will be the formula that we will going to utilize in that computation. Okay, there you have it. Okay, so let's start now. First, we will use this formula over here, right? So we will use this formula. So okay, so as we all know, VFY is 0. Okay, because that's the peak height. And let's write it first. Okay, let's write the formula first. Okay, so we have VFY is equal to VIY minus GT. Okay, so as we all know, this is 0. Alright, so since that is 0, so in order to compute for the time, so we will use the formula. Okay, so we will use the formula time is equal to VIY over G. Alright, so the negative is already eliminated in the process. So, next one. VIY, what is VIY? That is 10.26. Alright, so let me look at it. Let me have a peek at it again. Okay, so this is the range. Okay, so 10.26. Okay, we are on the right track. Alright, so that is 10.26 divided by the 9.81. Right, so don't forget, sorry, there's no 1/2. Alright, so divided by 9.81. So the time it takes to go on that peak height is 26 divided by or over 9.81. So that will be 100, okay, 1.05. Alright. So to be exact, that is 1.05 seconds. So we have now our time needed to compute number 2. Alright, so we have now the time needed to compute for number 2. Okay, so let's go number 2. So YF. Okay, so I will use green. Alright, so YF. Alright, so YF, this is the one that we are looking for. And the object comes from a certain height, that is 100. Alright, so let's write the formula first. 1/2 GT squared. Alright, so now, so to compute for the YF, so YI is 100 because that's our origin. Alright, plus, okay, what is the VIY? Alright, so the VIY is 10.26. Alright, then multiplied by the time that we got it from earlier computation. So we have 1.05 parentheses, then minus 1/2. Alright, 9.81, then 1. Okay, sorry. Okay, so let's erase that one. Okay, so 1.05 squared. There you are. There you have it. So now, if you do the math correctly, alright, so if you do the math correctly for that, so the answer there should be 100. Alright, so the answer on that should be 105.4 meters. Alright, so that will be your peak height or the y sub f. So, okay. So the complete answer is the peak height of the projectile is 105.4 meters. So that is the complete answer for this question on letter B. Okay. Now let's go now to letter C. Okay. Alright, so letter C. Okay, on letter C, we are asked to compute the velocity. Erase that one. Okay. So, let's compute for the velocity after 2 seconds. Okay, so what is the velocity after 2 seconds? And not only since we are talking about the velocity, it has a certain direction. So in this computation, the direction is also included. Alright, so this is how it looks like. Okay, so let's go back to the drawing that we did earlier. Alright, so this one. Okay, so suppose this is the 2-second mark. Alright, so this is the 2-second mark. So suppose this one, the one that we have right here, for example. Alright, so in the 2-second mark, you have your x component. Alright, so we have we can call it a v2x. Alright, next one. Alright, and also it has the y component. So we can call it as v2y. Alright, so we have the v2y and v2x. So we are looking for the velocity, which is this one. So this is the v sub 2 that we are looking for. Alright, now, what is the... Alright, so what should be? Alright, what should be the angle? Alright, what will be the direction? So these are the things that we are looking for. So this one, the magnitude and the direction of your projectile. Now, let's go back. Alright, so let's go back to our drawing. So let's redraw it here. Alright, let's redraw it here. So, we have... Okay, so we have first the v2x. There you go. So we have the v2x. And we have the Alright, so we have the V2Y. Okay. Next one, we have the missing, okay, so the missing thing that we have right here, or the one that is asked on the problem. So this is velocity after 2 seconds and the direction it is going. Alright. Now, what are the formulas that we will going to use? So let's write all the formulas once more. So number 1, we have x sub f is equal to v sub ix times time. Okay? Next, number 2, we have v sub f x is equal to v sub ix. Then number 3, we have y sub f is equal to y sub I plus v sub iy times time minus 1/2 gt squared. And finally, we have the v sub fy is equal to v sub iy minus gt. Alright, so there you go. Now, since we have the time here, we have the time over here, we can use this and this one. Alright, now, let's start using number 2. So I will use blue for number 2. Alright, so for the V2X. Now, how to compute for the V2X? Alright, so V2X can be... Alright, so V2X can be obtained by the idea of the horizontal motion is constant speed. Alright, so the x velocity, alright, so the idea is the x velocity is constant. So since that is constant, it means that whatever will be the Vix, alright, whatever will be the Vix should be the same value as your Vfx. Alright, so whatever the point, whenever or wherever the point it is, alright, wherever it is always equal. So it means that, okay, it means that if we go back to our computation moments ago, alright, so this is your Vix. So meaning to say that it tells us that at all, alright, at all position, alright, at all position on this trajectory, it is always equal to this value. Right? It is always equal to this value, which is 28.19. Whether it is 3 seconds, whether it is 4 seconds after the launch, 1 second after the launch, 5, or even 6, this is the value. Alright? So this will be the value. So we will plug it right here. So we already computed for the V2X, and that is 28.19 meters per second. So there you have it. Okay, so that's how number 2 works. Alright, so always take note that the x velocity is always constant at any point. Alright, next one. Our problem is number 4. Alright, because that is the VIY. It will be completely different because y velocity is, alright, so y velocity is accelerating. Okay, is accelerating. Right, so you should take note of that one. So it is not the same value that we have computed earlier ago. Alright, so earlier. Okay, so it is not the same thing. So we will use this one, okay, to compute for the VFY. Alright, so we will compute this one with the use of the VIY that we got from the component earlier and the time that we have right here on this problem. Alright, so we have... Okay, so let's compute for the VFY. So VFY is equal to, okay, so let's use that formula. So that will be 10.26 minus 9.81 times the time, which is 2 seconds. Okay, now if you do the math correctly, alright, so if you do the math correctly, so your V sub Fy is, alright, so your V sub Fy will be negative, alright, negative 9.36 meters per second. Now, how do we know that this is correct? Alright, so how do we know that this is correct? So negative. Okay, so let's put these important numbers inside the box. Right, so let's put these numbers inside the box. There you have it. Now, how do we know that we are correct? Okay, how do we know that we are correct? So, the answer is negative. So, meaning to say that your VFY is already going downward. Alright, it tells us that your object is now accelerating downward. So it is not anymore, alright, it is not anymore at the peak because earlier we compute for the peak at around 1 second. Alright, we computed for the peak at around 1 second. So meaning to say that after 2 seconds, your object now has already reached its peak height and moving towards now to the ground. Alright, it is approaching to the ground. So meaning to say, it is moving to the ground because that is negative. The velocity is negative. It indicates the direction of the object. It is going down. Meanwhile, the horizontal motion is still positive because that is constant. It is moving forward. It always moves forward. Alright, so that is positive. Alright, so now, since we have now the components, alright, so since we have now this and the V2x, we can now compute for the V sub 2 using the, alright, using the Pythagorean theorem. So the formula is V sub, V sub 2 is equal to square root of, alright, square root of 28.19 squared plus negative 9.36 squared. Alright, so if you do the math correctly, so that will be 29.70 meters per second. So that is your velocity after 2 seconds. Okay, so that is the velocity of the object after 2 seconds. So that is 29.70 meters per second. Next one. How do we find... Alright, so we already finished with this one. We are done with this. Next one. How do we find the... Alright, so how do we find the angle? Alright, so how do we find the direction? Alright, so in order to find the direction, we will use the formula theta is equal to tangent negative 1. Okay, tangent negative 1 and V sub Fy over V sub, V sub 2y. So let me erase that again. Okay, erase. Okay, so we have V sub 2y, okay, and divided by V sub 2x. Okay, there you go. Okay, so let's put on the values. Alright, let's put on the values there. So tangent, alright, negative 1. Okay, V sub 2y is, alright, so V sub 2y is negative 9.36. And we have the V sub 2x which is 28.19. There you go. Okay, now if you do the math correctly, okay, so if you do this 9.36 over 28.19, okay, so tangent negative 1, so 0.3320, so that will be, alright, so the answer will be 18, which is negative. Okay, so I will remove the negative. Instead, I will put a statement that corresponds to that negative. So the negative sign tells us that, alright, that the projectile is moving below the horizontal position or below the horizontal direction. Alright, so 18 degrees below horizontal. That is what the negative sign means. Alright? Or you can put there the negative if you want to. But, okay, in order to make our statement more satisfying, okay, so the answer is 18 degrees below horizontal is the direction of the projectile after 2 seconds with the velocity of 29.70 meters per second respectively. Alright, so I will box this one. Okay, so I will repeat again the answer. What is the velocity after 2 seconds? 29.70 meters per second at 18 degrees below horizontal. Okay, remember velocity is a vector quantity and it should always have a magnitude and a direction rather. Okay, so we answered now, or we already answered. Alright, let's go back to our drawing. Okay, so we already answered x sub f. we already answered peak height, and we already answered the velocity after 2 seconds. Alright, so in order to answer problems like this in the future, okay, one tip that I will give you is to practice more solving this kind of problem. So practice, okay? Practice makes not perfect but permanent. Okay, so practice makes permanent. Okay, so that is our sample problem, and let's go back to the main screen. Alright, so that is our sample problem, and I hope you did learn something from it. Okay, if so, just hit the like button, okay, on this video. And if you want to be updated with more videos like this in the future, click the subscribe and the bell notification beside it. Alright, and if you saw something on this video that is that you have any question, alright, on it, just put it in the comment section. And if you have suggestion about future videos to come, just write it down in the comment section. It will help me a lot on that. Alright, so that ends up our video lesson for a sample problem from projectile motion, and I hope you learned something from it. Stay safe everyone, and peace out.